Alrighty. How many rotations does it go in stopping? Okay. So this is going to be torque as I alpha. And I think what we're going to do here is we're going to find alpha, and then after we've found it, we're going to then solve a kinematic thing to figure out how many rotations it goes through. Okay, so I think we know everything we need to know to find the moment of inertia, right? So that's going to be 1/2 mr squared, which mass is 243, and radius is 1.7 meters. So now let's figure it out. 1/2 243 times 1.7 squared. 0.5 times 243 times 1.7 squared is approximately 351.135. Ooh, that's cool. That's a cool number. All right, and then I think we can find the torque. Torque is RF, right? And R is 1.7, and F is 8.5 newtons. Okay, so 1.7 times 8.5, somewhat surprisingly, is 14.45. And that's a 4. Right, so now I can find alpha. You guys ready for this? This is pretty exciting. So that number that I just got, 14.45, divided by that honking number there. It's not going to be a huge acceleration, is it? Okay, so alpha is 0.04115 radians per second squared. So now we're set. Now we can figure out the rotations it goes through. So theta is what we want to find, right? Initial, final, alpha, and t, right? Okay, so it stops. Okay, so this is a little bit awkward here. Presumably this was a negative torque, right, causing a negative acceleration. So I'm going to throw a negative sign in front of that. Like 0.04115 radians per second squared. Our final velocity is 0. Our initial velocity is 68 RPM, so 68 2 pi's in 60 seconds, right? 68 revolutions, 2 pi radians worth of angle in 60 seconds, right? So 68 times 2 pi divided by 60 is 7.1209 radians per second, right? And then we want to find this, and I guess we want to use one with no t, so that's omega final squared is 2 alpha theta, right? So alpha theta is, let's see. Okay, so 0 squared minus 7.1209 squared divided by 2 times negative 0.04115. All right, we can do this. Okay, so take the number that's on my calculator, square it, divide by 2, divide by that 0.041 number. And I get 616.1 radians, right? And then divide by 2 pi, because we want rotations, right? So divide by parentheses 2 pi is 98.05. Rotations. So 98.1 rotations. Yay. Okay, so what were our steps there? My first step was I realized I could calculate the moment of inertia, so I did it. My next step was I figured out I could find the torque, because I had R and F, so I did that. Third step was I figured out the angular acceleration. right? And then since it was slowing down, I just arbitrarily slapped a minus sign on there, right? Get a little free and easy here, right? And then I solved a kinematics problem. I had the initial velocity, the final velocity, the acceleration, and I used this guy to find the angle, and I got the answer. The answer is initially in radians, and I had to get rotations, right?